Hey guys, it's Miss Johnson. This is Friday's video, but honestly, it doesn't really matter which day you watch it. This is the video where I talk about your first portfolio project. Let me rant for a bit before I start doing math about what this portfolio is. This is your individual assessment for Unit 1. So, all the classworks are worth points. Those are all things that go in the gradebook. The other big things that are going to go in the gradebook are your group test. It's like the end of the unit test, and this portfolio. This portfolio is worth as much as the test. That's how it goes, So make sure to, give this your real attention. We'll have time to work on it in class. So I'm making this video to kind of talk about each of the sections and maybe refresh the rules that you'll use. But yeah, let's get going. This is kind of an algebra review packet, algebra and algebra 1 and pre-calculus. These are just the skills that I think are really important that we'll use over and over and over again when we're doing calculus problems. So we want to make sure that we have all this nailed down so it doesn't slow us down when we're actually learning new math. We want to have the old one airtight. All right, so part 1 is simplifying exponents. And that's going to basically boil down to 4 rules, right? So the first one is if you have like x times a, or x to the power of a times x to the power of b, so x to some power times x to some other power, you just add the exponents, right? And similarly, if we have x to a power divided by x to a different power, you're going to subtract the exponents. Make sense? The other one is if you have x to the power of a times y to the power of b to the power of c. So 2 things are happening here. The first thing is x to the power a times y to the power b. That's simplified. We can't do anything to that, right? The bases are different, so we can't really combine them in that way. But because we have the second thing going on, we have everything in this parentheses taken to the c power. We're gonna, oh shoot, x is first. We're gonna multiply those powers. Seems kind of good. And the last rule I want to talk about is when we write things, and I'll write this in 2 ways. When we have fractional powers, x to the 1/3, we can actually write that as the third root of x. And these are the same things, right? The other way I'm going to write that is if we have, if we start with the root, we can always move to the fraction. Cool. And then a secret 5th rule that I'm not even sure is on this this portfolio, but if we have a negative power, that just means we can take it to the opposite side of the fraction from which it started. So if we've got, x to the -3rd, that's the same thing as 1 over x to the 3rd. If we have 1 over x to the -7th, that's the same thing as x to the 7th. Anytime we have a negative in the exponent, we can get rid of it, quote unquote, get rid of it by moving it to the other side of the fraction and then keeping the number. All right, that's part 1. Feel free, if you want to pause this video in between parts, to kind of pause this, work on the portfolio, then watch when I'm, watch the part that I'm actually talking about, and then work on the part that I actually talked about. If you have any questions, you can either shoot me an email as they come to your head, or you can join into office hours if you're doing this during asynchronous time, or you can hit me up on Wednesdays. I've got the entire afternoon is just calculus office hours. All right, let's move to part 2, which is somewhere on this. It's right here. Okay, factoring. Step 1, so the big thing in factoring is always, 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 before you start, factor out the greatest common factor. So greatest common factor. And I'll show you what that looks like. Say we have something, this is going to be our example for this whole time. Say we have 4x squared plus 14x minus 30. This is like the weirdest one. The first thing we would do is say, wow, each of these numbers divides by 2. We're going to make our life easier, and number 1 we're going to factor out a 2. So, well, I'm not great at drawing. Step 0, basically before we start. Factor out greatest common factor. Nice. Okay. Step 2, if we have kind of the more normal looking one, where we just have like x squared plus 3x plus, 4 or whatever, we're looking for things that, we'll say 2, it's easier. We're looking for things that multiply to this number and that add to this number. So here we would say, 2 times 1 is 2, 2 plus 1 is 3. Bingo bongo, we did it. But this one's easier because our first term is 1. Basically, it's not there. We don't have a coefficient out front. But let's do a harder one, namely this one up top. Wow, I need to get better at erasing very quickly, but not there yet. Okay, so we factored out the 2. Let's just consider this part real quick. And then basically when we have our answer, we'll slap the 2 back on the front. But over here, we've got 2x squared plus 7x minus 15, and we want to factor that. You might remember the box and diamond or diamond and box method. We're about to do that now. First thing we do, we draw this diamond, then we draw this box. Boom, drawing pictures, my specialty. The top of the diamond is the 7. We just drag this 7 from the middle down to here. Then the bottom is like the first coefficient times the last coefficient, the A times the C. All right, fine. And then the other things we just get to fill out right away with no thinking is in the box, we put the first coefficient here and the last coefficient here, or the last term, right? And the first term and the last term. All right, new color. Now, the same thing that we were thinking of, the kind of the normal version, which is we're looking for things that add up to 7, but multiply to negative 30. Add to 7, multiply to negative 30. If you're struggling to think of things, like if it's just not coming to you straight away, that's fine. We'll write it systematically, right? Things that multiply to negative 30 are like 1 times 30, where one of them's negative. Fine. 2 times 15, where one of them's negative. 3 times 10, where one of them's negative. And then I think 5 times 6 is the only other one. That seems kind of right. And then we can add them, right? This one adds to like 29, bad. This one adds to 13, bad. This one adds to 7, amazing, right? So if you're ever having trouble thinking of what adds to something and multiplies to something else, it's nice to write them out systematically and just check so that we don't have to, sit around and wait for inspiration. Okay, the numbers we came up with here are the other 2 numbers in our box. Except they have an X with them because they're basically adding up to replace this 7. Okay, I'm gonna switch back to blue because we're getting to our final answer. Now we want to say, okay, we want to fill out the numbers here, 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 and here, such that it's the greatest common factor, or it's things that multiply to get these boxes. So 2x squared and 10x both have a 2x involved. Sure. 2x times this something is going to equal 2x squared, so that something has to be just a regular x. Fine. This x times this something needs to be negative 3x, so that's just going to be minus 3. And then minus 3 times whatever goes here needs to be negative 15, which means this is 5. Positive 5, right? And then we're almost done. This part and this part are our 2 factors. So when we factor this, we end up getting x plus 5, 2x minus 3. Nice. So if we were finishing out this problem, right here. We would just rewrite our 2 because we didn't change that. And then this part that I've underlined in the red bracket or whatever, we get to replace by its 2 factors. Pretty good. There are a couple patterns that you'll explore in the portfolio, but that's for y'all to explore. All right, again, feel free to pause here, work on the factoring part, and then when you're finished that, come back, watch the next part of the video. I'm going to keep going because I'm not making 5 videos. I'm making 1 video. All right, part 3 is kind of, I said fractions, but I really mean rational expressions. So if we're adding or subtracting any fraction, just with numbers, just with variables, with kind of polynomials on top and bottom, aka rational expressions, the first thing you're going to do is find a common denominator, right? Well, okay, step 0 is always simplify. You'll always see me call this step 0. If there's ever a way to make your problem easier, do it right away. Don't make your life harder. Okay, so step 1, find a common denominator. And then step 2 is just add or subtract the numerators. There's no way that's how you spell numerators. Okay, that's how it goes. Let's do an example. So if I had a plus 6 minus a plus 3, I'll do plus. Then this is 3a minus 6. Right? First, can I simplify? Looks like no. Sad. So I'm going to keep the denominator. Right? It's the same denominator, so we don't need to find a common denominator. It's already common. And then we're going to add the tops. So a plus a is 2a. 6 plus 3 is 9. All right. And then we can check to see if we can simplify. But we really can't, so we're done. All right. This is for adding and subtracting. For multiplying or dividing. That's your next. Guess what the step 0 is, guys? It's simplifying, right? If you can simplify, always simplify. When you're multiplying and dividing, this includes factoring, right? So say we had, I don't know, 2x plus 4 over 3x minus 5 times, what do I want to do? X squared minus 4 in the bottom, and then something like 6x minus 10 on the top. Okay, first step is factor. You can pull a 2 out of this top one. 2x plus 4, greatest common factor is 2. This is simplified. 6x minus 10, you can pull a 2 out. And then x squared minus 4, this is x minus 2x plus 2. And that's something we explored in the factoring thing, so I'm kind of expecting you to know it at this point. Okay, so now we can simplify. We can say, oops, it's fine. We can cancel this, let me make a different color. We can cancel this x plus 2 factor with this entire x plus 2 factor. We can cancel this 3x minus 5 with this entire 3x minus 5. We can't cancel the 2's with the 2's because they're both on the numerator. We want to cross cancel, right? So this becomes 2 times 2 on the top is 4. And then the only thing on the bottom is x minus 2. And we are good. That's a bad box, but that's where we are. Yeah. The only other thing I want to mention for this specific section, and I'll put it up here. I'll try to put it up here, is that if you ever have something that looks like A divided by B over C divided by D, right? So the fraction A over B divided by the fraction C over D, that's the same as this, which is the same as A over B times D over C, right? When you're dividing fractions, you flip the second and multiply, right? It's this keep, flip, change. So we kept A over B, or keep, change, flip, right? We kept A over B, we changed divide to multiply, and we flipped C over D. Okay, that's part 3. Part 3 is fractions. Part 4 is solving. So this one's kind of wacky. Honestly, this one I'm more into y'all experimenting, seeing what you can do, trying to figure it out. But the key thing I'm gonna mention, I'm gonna write one out real quick, which is if we start with x over, sorry, I've got my notes off to the side, minus y times x over, here's 10. And it tells us to solve for x. We can do 2 things here. We can see that, here, do 2 things. There's x's in both of these. So we can actually just factor it out. Right, factor out an x. And then anytime we want to get x alone, when it's x times something, it does not matter how complicated or awful that something looks like, we can divide both sides by that something and cancel it out, right? So that looks like 10 divided by, and that's a finished problem. Yay. The other way we could do it, so that's one way. The other way we can do it is more of like a catch-all way to do any fraction problem, which is we can multiply by the denominators, right? So if we multiply, I'm just going to write this over again. Right? If we multiplied all of these by y plus 3 and y minus 2, this part would cancel, this part would cancel, we'd get x, xy, and then this awful 10 thing. Kind of fine, I'll move my head. Great. And then again, we can say, oh, these actually, yeah, that's fine. So we can distribute all this. I really made this problem long, huh? We can group all the x's. So everything with an x is on this side, perfect. Everything with a y is on that side, or everything without an x is on that side, sorry. Because all of these have, we have actually like terms we should combine. Boom. Okay, everything on the left-hand side has an x, which means we can factor it out. And then you guessed it, we get to write this one more time. We divide both sides by this non-x part, negative 2y minus 2 minus y squared. This all cancels out with this, so we just have x is equal to this giant thing. And I know what you're saying. I know what you're saying. The box in blue is not the same as the box in red. It is. It is, it's just simplified a different way. And in calculus, honestly, a lot of times the simplification is going to be looking like this. It's going to look pretty monstrous. And instead of like rationalizing denominators and making sure everything looks cute, we're just going to say that's good. And grading is going to be a little bit harder for me because I'm going to have to look at both of these and say that's the right answer. But for you guys, that's good. That's totally fine. So yeah, for part 4 for solving, basically just get, if you're solving for E or if you're solving for X or if you're solving for H or whatever, make sure everything on one side has the thing you're solving for and everything that doesn't have that thing is on the other side, and then do a bunch of division. That's kind of the philosophy. And then finally, again, pause between these parts. Pause, listen to me, work, listen to me, work. But anyways, welcome to part 5. Function composition. I'm just going to do some examples. I think that's the best way to learn these. So if, say, f of x is x squared and g of x is x to the third, right? Let's let that be true. And then over here, we can do some stuff. So if I say, what is wire? I say, what is like f of 8? It's the square root of 8. We're done. You don't need to plug that into a calculator. Square root of 8 is a fine number, right? What if I say, what is g of x plus 8? I'd say, okay, well, g is something to the third, right? X to the third, just something to the third. And when I say, what's g of x plus 8? It's just x plus 8 to the third. Right? Over here, this function, when we say g of x, we just mean g of something. And that something needs to be plugged in here when we actually end up plugging it in. Right? So if we wanted to say g of 10, it'd be 10 to the third. If we wanted to say g of x plus 8, it's x plus 8 to the third. Totally fine. What if we wanted to say f of x to the fourth? All right. It's the square root of x to the fourth. We can make this look a little bit better, though, right? Because we know that the square root is actually just to the power of 1/2. And we know that when we've got a power raised to a different power, it's just multiplying. Right? And 4 times 1/2 is 2. So that's a little nicer. That's just me showing off, though. If I wanted to do f of g of x, I'm actually going to instantly rewrite this with different colors, which is f of something, and the something inside is g of x, right? So I'm going to write these. I'm going to say, okay, it's f of something. F of something is the square root of that thing. Okay, and I say, what is that thing? Well, that thing is whatever g of x was. And again, we could have written this as 3/2 if we wanted to. Great. What if we had g of x for some inception, right? We say this outside g is just something to the third. What's the inside g? Something to the third. And then our exponents rules say this is x of 9, x to the power of 9. All right, guys, that's the quick rundown on the 5 different parts of your algebra review portfolio for Unit 1. I really think this is important stuff. I think it's important that we kind of remember what we know and learn what we don't so that we have a kind of a smooth sailing during the tricky algebra parts of calculus. All right, guys, again, always, if you need help, email me, come to office hours, ask your group. You have recourses. Please, please, the worst thing to do is sit at home and be stressed about math. Reach out. Talk to me. Thanks, guys.